Vocabulary is so important in any mathematics class, but even more so in statistics. When I, as an instructor, say some word, such as proportion or population or inference, you as the student must know what it is I'm speaking about. In other words, you and I must speak the same language. So in this video, we're going to go through some initial vocabulary, some vocabulary that is common to statistics. First of all, getting back, and it's something that I will continue to focus on throughout the year, and that is the process that we're doing in this class is called statistical analysis. Research is an organized and systematic way of finding answers to questions, and statistical analysis is one of the tools used to find answers. Again, a famous saying from an individual named Moore, that statistics is the process of answering questions but with incomplete information. So here is a visual of the process of statistical analysis. You have a population, a group of individuals or items that you're interested in. From that population, what you would like to do is you'd like to make some estimate about, and I'm going to circle this, you'd like to make some estimate about something about the population. A parameter is some aspect, some characteristic of the population. It might be the mean of the population. It might be the proportion of the population. Generally, populations are inaccessible. You cannot obtain all individuals. You don't have the money, you don't have the time. But what you can do is you can obtain a sample of the individuals from the population. And you do that hopefully, and not always, but hopefully through some random selection process. So this would be called a random sample if it's selected via some random process. From that sample, you calculate the statistics. And the statistic is essentially something that is calculated from the data that's collected from the sample. It might be the sample mean or the sample proportion. So note the difference. A parameter is for the population mean. A statistic is for the sample mean. P for population, S for statistic. Based upon that statistic, you make an inference, an inference being an educated guess about the parameter that you want to know about. So here are some definitions about the vocabulary we're going to be speaking about. The population is the subjects or items about whom the research question is asked. So be careful there. With population, it doesn't mean the population is all human beings on Earth. It might be that your population are only those individuals in Cincinnati who might be customers of your business. A parameter is some characteristic of the population. A sample is a subset of the population about whom data pertaining to the question is collected. So the sample is again a subset of the population. You collect data from that sample, and that data allows us to answer the questions that are being posed. The variable of interest is the data that's collected from each member of the sample that will allow us to answer that question. Statistic is some value calculated from the sample data. So it might be a sample proportion or percentage. It might be a sample mean. It might be a sample standard deviation. There's lots of statistics. All statistics, however, are calculated from samples. And lastly, a plausible inference, which in the last slide I said was an educated guess, is some conclusion reached about the population based upon the sample data and statistics. So when I ask you to state a plausible inference, what you want to make sure you do is essentially say something about the population based upon the sample data you have or based upon the sample data that you might have. Here's an example. An owner of a hat shop in a large city intends to order a particular variety of hats in a variety of sizes. The question is, how many of each size should be ordered? So I'm going to work through some potential questions that you might see on a test or quiz. The population in this situation would not be all people. It would be all potential buyers of this variety of hat. What is the parameter of interest in this situation? Well, you want to determine as a buyer, as a purchaser, rather, how many hats you should order of each size. So the parameter of interest is the percentage or proportion of all potential buyers that require each hat size. Again, note, this is the idea of a population. You couldn't do that. You couldn't possibly go out and measure every individual's head size who might potentially be ordering this hat or buying this hat. It's what we'd like to estimate. But the reason we can't go out and do it directly is we can't ask everybody. Okay, continuing with this example, what this hat shop owner did was went out, essentially based upon perhaps historic data or collecting a sample of individuals that were in his or her shop. This hat shop owner collected a histogram, which is again essentially a collection, a description of the data, collected data on hat size, which is measured by head circumference, from 142 buyers of that hat. The histogram above, okay, basically shows how many of those 142 individuals fell into each category. So for example, the histogram says that approximately, and I'm going to write this up here, approximately, looks like about 46 individuals fell in the category from 56 centimeters to 58 centimeters. We don't know how many are where they fall in that category rather, but about 46 individuals fall in of the 142 fell in that category. So let's continue with our questions. What is the sample in this situation? The sample would be the 142 buyers of that particular hat. The 142 buyers for whom the owner collected data. What is the variable of interest in this situation? The variable of interest is the data that's collected. So what data was collected? I often say, if you open up the spreadsheet and the spreadsheet of the data was sitting in front of you, what would you see? You would see the head circumference of the buyers, the 142 buyers, or of the potential buyers. So you're interested in the head circumference. That's the data that would be collected either from the sample or, if you could do it, from the population. Lastly, based upon this sample data, what's a plausible inference that we could reach? So what I did was I looked at this histogram and I estimated that there were about 18 individuals that fell in that category. And, about 18 that fell there, about 7 that fell there. So together in those two categories there are about 25 individuals. So here's an inference that I could reach. Based upon the sample data, we estimate that 25 out of our 142, which is about 17.6% of all buyers, have a head circumference that is greater than 60 centimeters. In other words, what I did was I said, based upon the sample data, what can I say about the population, about all potential buyers? That's what I'll be looking for on your homework, on your quizzes, is based upon the sample, what can you say about the population, about all potential buyers of this hat? Let's do one more example. Here's one example, essentially similar to what's in a potential test question or a question from the homework. A group of students in a local high school conduct a survey of the student body to assess their opinions, approve or disapprove, about a proposed school coffee shop. The survey resulted in 200 responses. So here's some questions. What is the population of interest? or excuse me, what is the population in this situation? Okay, the population would be, and let me do a little bookkeeping here. Oh, you hear my dog barking in the background. He tends to do that at times. There we go. Okay, let me go back to this question. What is the population in this situation? All students at this school that would purchase coffee at the shop. Again, it might not be all students, but it's at least all the students. Who am I interested in? All the students at the school that would purchase coffee at the shop. In voting, you often see that as they distinguish between voters and likely voters. What is a sample? The sample would be the 200 students at the school that responded to the survey. That's a subset of the population. The variable of interest, so what do we collect from each of these 200 students? Or what would we collect from the population? We'd collect the students' opinions, approve or disapprove, about the proposed shop. Note, again, identifying the type of data this would be. The students would respond approve or disapprove. This is qualitative data and nominal. Lastly, what is a plausible inference that you could reach in this situation? What's something, if you had the data in front of you, what's something that you might be able to say about all students at the school? So again, you don't have the data, so we have to be a little creative here. Let's say based upon the 200 responses, what we might have seen is that a majority of them, of the 200, were in favor of the proposed coffee shop. So here's a plausible inference based upon 200 responses. We might conclude that a majority of all potential coffee drinkers at the school approve of the proposed coffee shop. Note that you don't have the data, but if you did, and if it showed that the students were in approval of the coffee shop, that would be a plausible inference.